chemical substances and chemical reactions. Learning objectives. Elements. Symbols of elements. Chemical reaction. Characteristics of a chemical reaction. Types of reaction. All the matter solids, liquids and gases are made up of elements or compounds. On the basis of physical state, matter is divided in three states. But chemically matter can be classified into elements, compounds, and mixture. Any kind of substance, like your book, pen, pencil, shirt, paint, chair, table, foods, all are made of element or compound or mixture. In this chapter you will learn about the chemical nature of a substance. You know that all the substances are made up of matter. Matter is divided into two categories: mixture and pure substance. In a mixture there is no definite composition, for example air and soil. Whereas, pure substances have definite composition, for example, iron, copper, sodium chloride, common salt, etc. Pure substances are further divided into two categories: elements and compounds. Here we will discuss individually about elements, compound and mixture. Matter. Mixture. No definite composition. Pure substance. Fixed composition. Elements. Compounds. Elements. An element is a pure substance that cannot be broken into simpler substance and is made up of only one kind of atom. There are 115 elements discovered, among them only up to 92, uranium, are found in nature and most are man-made elements. Different elements are made up of different kinds of atoms. But all the atoms of one element are identical. For example, hydrogen contains hydrogen atoms which are all identical. Oxygen contains oxygen atoms, which are identical. But hydrogen atoms are different from atoms of oxygen. Atoms and molecules. You know that elements are made up of atoms. Atoms of most of the elements are very reactive. They exist in combination with the atoms of same element or another element. So the atom can be defined as an atom is the smallest particle of an element which takes part in chemical reaction. Molecule is the unit of pure substance, elements or compound, which exists in free state. Classification of elements. There are approx 115 elements discovered. It is very difficult to study all of them. So the elements have been divided into three groups. 1. Metals. 2. Non-metals. 3. Inert gases or noble gases. 1. Metals. General characteristics of metals are as below. I. Metals are lustrous or of shining nature, for example aluminium, silver, gold. 2. Metals are good conductor of heat and electricity, for example cooking utensil and electric wire are made up of aluminium and copper wire, etc. 3. Metals are ductile, i.e. they can be drawn into wire. 4. Metals are malleable, i.e. they can be beaten into thin sheet, for example aluminium sheet. V. Metals are solid at room temperature except mercury. Y. Metals are sonorous, means producing sound on hitting. 7. Metals have high boiling and melting points. Symbols of elements. A symbol of an object image represents something. For instance, in mathematics, plus represents addition, minus represents subtraction. Similarly, we use symbols to denote elements for our convenience. In olden days, scientists used pictorial symbols to represent elements. John Dalton, a British scientist, used his own set of symbols. Symbols used by alchemists. Gold, silver, lead, mercury, phosphorus, sulfur, iron, tin, water, fire, common, salt. Symbols used by Dalton: gold, sulfur, lead, mercury, phosphorus, platina, oxygen, hydrogen, silver, carbon. A Swedish chemist J.J. Berzelius first proposed the modern system. In this system, an element is represented by first letter of its name. For example, carbon is represented by C. Some elements are represented by two letters, the first letter in capital followed by a small letter from the name. This is in order to distinguish between elements whose names start from with the same letter. For example, carbon, cobalt and calcium are represented by C, Co and Ca. Some elements' initial letter is taken from their Latin name, like gold. Latin name is aurum, so its symbol is O. Symbol of some metals elements. S.No. Name in English. Name of other language. Symbol. 1. Sodium. Natinum, Latin, Na. 2. Magnesium, Mg. 3. Aluminium, Al. 4. Potassium, Kalium, Latin, K. 5. Calcium, Ca. 6. Chromium, Sar. 7. Manganese, Mn. 8. Iron, Ferrum, Latin, Fe. 9. Nickel, Ni. 10. Copper, Cuprum, Latin, Cu. 11. Zinc, Zn. 12. Silver, again Rtum, Latin, Ag. 13. Tin, Stannum, Latin, Sn. 14. Platinum, Pt. 15. Gold, Aurum, Latin, O. 16. Mercury, Hydrogenum, Latin, Hg. 17. Uranium, U. 18. Thorium, Th. 19. Radium, Ra. 2. Non-metals. There are 22 non-metal elements which behave like non-metals. General characteristics of non-metals are as below. I. At room temperature, non-metals are either solid or gas except bromine. 2. Non-metals do not have lustrous property or shining surface except iodine. 3. Non-metals are bad conductors of heat and electricity except graphite. 4. Non-metals are non-ductile, i.e. they cannot be drawn into wire. V. Non-metals are non-malleable, i.e. they cannot be beaten into thin sheet. Y. Non-metals are non-sonorous, i.e. sound cannot be produced on hitting. 7. Non-metals have low melting and boiling points. Some common non-metals and their symbols. S.No. Non-metals state at room temperature. Symbols. 1. Hydrogen, gas, H. 2. Nitrogen, gas, N. 3. Oxygen, gas, O. 4. Fluorine, gas, F. 5. Chlorine, gas, C. 6. Bromine, liquid, Br. 7. Iodine, solid, I. 8. Carbon, solid, C. 9. Sulfur, solid, S. 10. Phosphorus, solid, P. 11. Silicon, solid, C. 3. Inert gases or noble gas. There are some elements, 6 elements, which do not react with any other element or their atoms. These are only found in air and in very small traces. That's why they are called inert gases or noble gases. Noble gases and their symbols. Inert gases. Symbols. Helium, He. Neon, Ne. Argon, R. Krypton, Kar. Xenon, Z. Radon, Rn. Compounds or pure substance. A compound is a pure substance formed by the chemical combination of two or more elements in a fixed ratio, for example common salt, NaCl, and water, H2O. You already know that a molecule is the smallest particle. All molecules of a compound are identical. That's why we say a compound is a pure substance. For example, a molecule of sodium chloride, NaCl, contains one atom of sodium, Na, and one atom of chloride, Cl. Water, H2O, contains 2 atoms of hydrogen and 1 atom of oxygen. It is combined together in the ratio of 1:8 by mass. The combined form of symbol of elements from a chemical compound is called chemical formulae. Some common compounds of acid, base and salt formulae are given ahead in the table. Chemical formulae of some common acids. Name, formula. Hydrochloric acid, HCl. Sulfuric acid, H into 2 SO into 4. Sulfurous acid, H into 2 SO into 3. Nitric acid, HNO into 3. Nitrous acid, HNO into 2. Carbonic acid, H into 2 CO into 3. Chemical formulae of some common bases. Name, formula. Sodium hydroxide, NaO. Potassium hydroxide, Co. Calcium hydroxide, CaO into 2. Magnesium hydroxide, MgO into 2. Aluminium hydroxide, AlO into 3. Ammonium hydroxide, NH into 4O. Chemical formulae of common chloride salts. Name, formula. Sodium chloride, NaCl. Potassium chloride, KCl. Calcium chloride, KCl into 2. Magnesium chloride, MgCl into 2. Aluminium chloride, LCl into 3. Zinc chloride, ZnCl into 2. Ammonium chloride, NH into 4Cl. Chemical formulae of common nitrate salts. Sodium nitrate, NaNO into 3. Potassium nitrate, KNO into 3. Calcium nitrate, CaNO into 3, into 2. Magnesium nitrate, MgNO into 3, into 2. Ammonium nitrate, NH into 4 NO into 3. Silver nitrate, AgNO into 3. Zinc nitrate, ZnO into 3, into 2. Chemical formulae of some common sulfates. Name, formula. Sodium sulfate, Na into 2 SO into 4. Potassium sulfate, K into 2 SO into 4. Calcium sulfate, CaSO into 4. Aluminium sulfate, Al into 2 SO into 4, into 3. Zinc sulfate, ZnSO into 4. Iron sulfate, FeSO into 4. Copper sulfate, CuSO into 4. Silver sulfate, AgSO into 4. Chemical formulae of common carbonates. Name, formula. Sodium carbonate, Na into 2 Co into 3. Potassium carbonate, K into 2 Co into 3. Calcium carbonate, CaCO into 3. Magnesium carbonate, MgCO into 3. Aluminium carbonate, Al into 2CO into 3, into 3. Zinc carbonate, ZnCO into 3. Iron carbonate, FeCO into 3. Copper carbonate, CuCO into 3. Chemical reaction. You know that many chemical changes take place around us, such as milk changes into curd, digestion of food in our body, rusting of iron objects, burning of fuel, etc. During the change process, molecules of one substance undergo chemical changes and form new molecules of substance. In the scientific language, a chemical equation consists of symbol of elements or formula of compound. The original substances, which undergo changes, are known as reactants, and new substances formed are called products. A chemical reaction can be defined as when one or more substances, elements or compounds, undergo a chemical change, either absorbing or releasing of energy, and form new substances called chemical reaction. Scientists study the properties of the substances and the chemical changes take place during reaction for the benefits of mankind. Wide range of plastics are examples of these benefits. Conditions of a chemical reaction. 1. One or more substances must undergo a chemical reaction. 2. The releasing or absorbing of energy must occur in the reaction. 3. There must be one or more new substance produced after reaction. Characteristics of a chemical reaction. In a chemical reaction, the reactants being converted into products are characterized by the following features. 1. Evolution of gas. Some chemical reactions produce gas. The gas can be identified by testing it. The evolution of gas is shown by an arrow pointing upward. For example, when zinc granule reacts with dilute sulfuric acid, hydrogen gas is evolved. When a matchstick is brought to the gas, it burns with a pop sound. Zn plus H into SO into 4. Zn SO into 4 plus H into zinc plus sulfuric acid. Zinc sulfate plus hydrogen gas. 2. Change of state. In some chemical reactions, the physical state of reactant undergoes changes. H into 2 plus O into 2. H into 0. Gas. Gas. Liquid. Hydrogen gas plus oxygen gas. Water liquid. 3. Changes of color. In some chemical reactions, the reactants lose their color. In such cases, the reaction is characterized by the color of products. For example, when green-colored copper carbonate is strongly heated, a black residue of copper oxide is produced. QCO into 3. Heat. QO plus CO into 2. Copper carbonate. Copper oxide. Carbon dioxide. Green color. Black color. 4. Formation of precipitate. When two chemicals, normally in solution state, react, an insoluble substance is formed. The formation of precipitate in a chemical reaction is shown by an arrow showing downward. For example, when silver nitrate, colorless, is mixed with a solution of sodium chloride, colorless, a white precipitate of silver chloride is produced. AgNO into 3 plus NaCl. Ag plus nano into 3. Silver nitrate. Sodium chloride. Silver chloride. Sodium nitrate. Colorless. Colorless. White. 5. Energy changes. Almost all reactions are accompanied by energy. During the reaction, energy is absorbed or released. When energy is released in the reaction is called exothermic reaction. For example, when carbon burns in air, heat is released. C. Carbon plus O into 2, oxygen gas, CO into 2, carbon dioxide, plus heat. When a reaction requires energy to initiate the reaction, it is called endothermic reaction. For example, when calcium carbonate is heated, it produces calcium oxide and carbon dioxide. CaCO into 3, calcium carbonate, plus heat, CaO, calcium oxide, plus CO into 2, carbon dioxide. Types of reactions. Chemical reactions can be classified into the following categories. 1. Combination reaction. 2. Decomposition reaction. 3. Displacement reaction. 4. Double displacement reaction. 5. Oxidation and reduction reaction. 1. Combination reaction. When two or more elements or compounds combine to form a single substance, it is called combination reaction. For example, when magnesium burns in air, it produces magnesium oxide. Mg plus O2 to MgO. When hydrogen burns with oxygen, water is produced. 2H2 plus O2 2H2O. 2. Decomposition reaction. The reaction in which a single compound splits into two or more simpler substances, it is called a decomposition reaction. For examples, when calcium carbonate is heated, it gives calcium oxide and carbon dioxide. CaO3 CaO plus CO2. When calcium oxide is mixed with water, calcium hydroxide is produced. Cow plus H2O O2. 3. Displacement reaction. The chemical reaction in which one least reactive element is replaced by a most reactive element is called a displacement reaction. For example, when granules of zinc metal are placed in copper sulfate solution, copper is replaced from copper sulfate by zinc. QSO4 plus Zn SO4 plus Cu. Activity 3.1. To study the reaction between iron and copper sulfate solution. Take 50 cc of copper sulfate solution in a beaker. Hang an iron nail with the help of a thread into the solution. Wait for 5 minutes. You will find that a reddish color, copper, is deposited on the surface of nail. This proves that iron displaces copper from copper sulfate solution. 4. Double displacement reaction. The reaction in which two compounds react with exchange of their atoms or elements is called double displacement reaction. For example, when silver nitrate solution is added to sodium chloride solution, a white precipitate of silver chloride is formed. AgNO3 plus NaCl AgCl plus NaCO3. In the above reaction, silver is replaced by sodium nitrate. 5. Oxidation and reduction reaction. When in a reaction, oxygen is added or addition of oxygen in a reaction is called oxidation reaction. For example, when carbon combines with oxygen, carbon dioxide is produced. C plus O2 CO2. Removing of oxygen from a compound in a reaction is called reduction reaction. For example, when copper oxide reacts with hydrogen, copper is liberated. Q plus H2Q plus H2O. Q keywords. Element. A pure substance which is made up of only one kind of atoms. Compound. A pure substance made up of two or more elements in a fixed ratio. Atom. Smallest unit of element which takes part in a chemical reaction. Molecule. Smallest unit of a substance which exists in free state. Symbol. Symbolic representation of elements. Reactant. The substance which undergoes a chemical reaction. Product. The substance which is formed after a reaction. Chemical formula. The symbolic form of a chemical compound. Exothermic reaction. The reaction which produces heat energy. Endothermic reaction. The reaction which requires heat to initiate reaction. Combination reaction. When two or more substances react and form one substance. Decomposition reaction. When a compound breaks and produces two or more than two substances or compound. Displacement reaction. When a more reactive element displaces a less reactive element from a compound. Summary. Substances are divided into two categories, pure and mixture. Pure substances are again divided into elements and compounds. An atom is the smallest particle of an element. It may or may not exist independently. It takes part in a chemical reaction. A molecule is the smallest particle of an element or compound which exists in free state. A compound is a pure substance formed by a chemical combination of two or more than two elements in a fixed ratio. All 115 elements are divided into metals, non-metals and inert gas. Most of the elements are of metallic nature. The symbol of an element represents the elements and one atom of elements. The combined form of symbols of elements makes the chemical formula. When one or more elements undergo chemical change by releasing or absorbing energy, it is called a chemical reaction. Chemical reaction is characterized by evolution of gas, change of color, precipitate formation, energy change and change of state. A chemical reaction can be divided into a combination reaction, decomposition reaction, displacement reaction, double displacement reaction, oxidation and reduction reaction.